We're going to look under the hood and see exactly how physical phenomena in the real world get transformed into actionable digital intelligence. Let's get into it. 21.1 billion. Let that sink in for a second. That's the projected number of connected IoT devices worldwide by 2025. I mean, we are way past just connecting computers and smartphones, right? We're talking factory equipment, wearable health monitors, autonomous vehicles, even sensors sitting out in a cornfield. And honestly, managing a scale that massive, it absolutely requires a highly structured, incredibly robust system. Okay, so here's our syllabus for today's explainer. We're going to trace the data journey straight up the 4-layer IoT architecture. We'll start with the ladder of knowledge, then move through the perception, network, processing, and application layers before finally wrapping up with connected security. Section 1, the ladder of knowledge, upgrading data to intelligence. You see, in IoT, we're not just blindly moving data from point A to point B, we're actually upgrading it. We take raw sensory inputs, turn them into structured info, and eventually into actionable intelligence. And this whole upgrade relies on a fundamental principle: sensor, processor, actuator. First up, sensing, literally just grabbing data from the physical world. Next is processing, where we add a bit of intelligence and prep the data. And finally, actuation. This is where the system makes a choice that physically changes something in the real world. Think adjusting a smart thermostat or instantly shutting down a faulty piece of factory machinery. This continuous loop, that's what drives literally all IoT interactions. Moving on to Section 2, perception, sensing the world, the physical foundation. Now, right at the base layer, the critical difference is really about the types of data our sensors are picking up. On one hand, we've got analog signals. These are continuous. Think of the mercury in a thermometer gradually rising. But as you know, microcontrollers only speak digital, ones and zeros. So those continuous analog signals have to be routed through an analog to digital converter, or an ADC. Now, on the flip side, we have digital signals. These are discrete. They're just simple on or off states, kind of like a motion detector getting tripped. Straightforward, right? But here's the catch. If every single sensor out there constantly blasted every tiny piece of raw data straight up to the cloud, well, the network would completely collapse. It'd be chaos. That's exactly where edge processing comes to the rescue. Instead of sending the whole shebang, these little constrained devices are actually pretty smart. They filter out all the useless background noise and only flag the important events locally, right there on the hardware itself. And doing this is absolutely vital because it massively reduces network bandwidth and, crucially, saves battery power. All right, Section 3, network, connecting the devices, bridging the gap. So once our data is captured and pre-processed at the edge, it's got to travel. And the make or break decision here? Choosing the exact right protocol by perfectly matching the technology to your use case. I mean, you'd obviously use Wi-Fi for a high-bandwidth smart home setup, right? And maybe Bluetooth Low Energy or BLE for short-range stuff like a smartwatch. But you would never, ever use high-drain Wi-Fi for a battery-powered agriculture sensor sitting 3 miles out in a cornfield. No way. For that, you need a low-power, long-range protocol, something like LoRaWAN. Meanwhile, for real-time mission-critical stuff, say autonomous vehicles where a millisecond delay is a disaster, 5G is absolutely the gold standard. But that raises a big question. How on earth do all these completely different, totally incompatible protocols actually talk to the broader internet? Well, they do it through an IoT gateway. Honestly, gateways are kind of the unsung heroes of this entire architecture. They essentially act as universal translators. They bridge our localized, low-power, non-IP devices directly to that massive cloud infrastructure, making sure everything can actually interoperate across the whole network. Up next, Section 4, processing, edge and cloud, where data becomes knowledge. Following our little packet of data further up the ladder, we finally arrive at the brain of the operation. Now, in modern IoT, we use a strategy called hierarchical offloading. Essentially, we're just dividing the labor. Edge and fog computing sit way down close to the physical devices. They handle all the real-time, ultra-low latency processing, the immediate split-second reactions. Cloud computing, though, that's your heavy lifter. The cloud takes care of the massive historical data analysis, the near-infinite storage, and those incredibly complex AI workloads that just physically cannot be crunched locally on a tiny sensor. And to prep all that data for the cloud's heavy lifting, we rely heavily on the ETL pipeline: extract, transform, and load. It's exactly what it sounds like. We extract data from thousands of scattered devices, we transform it, basically cleaning out the junk and formatting it, and finally, we load it into huge, scalable databases. Look,
With IoT on track to generate a mind-blowing 79.4 zettabytes of data a year by 2025, without a solid ETL pipeline, it would just be a tsunami of unreadable digital garbage. This pipeline is literally the only way to make it make sense.
Which brings us to Section 5, Application, Delivering Smart Services, the Economic Impact. So, at last, our perfectly processed, squeaky clean data reaches the top of the ladder. This is where the real-world economic value actually gets generated. Right now, manufacturing is completely leading the charge, making up 34% of adoption. That's mostly being driven by stuff like automated quality control and predictive maintenance. But check out healthcare. It's growing at an incredible 32.5% compound annual growth rate, mostly thanks to remote patient monitoring. And then you've got retail, sitting at a 61% adoption rate, using it to track inventory in real time and massively slash shrinkage. When these four architectural layers, perception, network, processing, and application, all sync up and work together flawlessly, the results are literally game-changing. By 2025, IoT is projected to have a global economic impact of up to $6 trillion. Trillion with a T. The efficiency gains and the sheer cost reductions we're seeing across all these different industries are just absolutely staggering. Let's look at our final section. Section 6, Security in a Connected World, Protecting the Architecture. Here's the sobering truth, though. All of that immense value we just talked about completely hinges on security. When you're managing a network of networks this gigantic, you are introducing some incredibly deep systemic vulnerabilities. And honestly, the challenges are daunting. We're dealing with the very real risk of physical hardware tampering out in the field. We've got nasty malware and botnets, like Trojans, that can totally hijack and disable entire systems. Plus, we're basically navigating a wild west of over 620 different IoT platforms right now, which means a severe lack of standardization. And maybe the toughest hurdle? A lot of these tiny edge devices just don't have the computing juice to handle heavy encryption. So the takeaway here is that security absolutely must be embedded deep into every single layer from day one. You can't just slap it on as an afterthought. Well, that brings us to the end of Lecture 2. We've tracked the entire data journey starting from a tiny physical sensor all the way up to a multi-trillion-dollar cloud application. Now, as the future engineers, architects, and consultants who are actually going to be out there building, optimizing, and, most importantly, securing this crazy complex architecture, I want to leave you with one final critical thought to chew on. How do you see IoT shaping the entire future of electrical engineering? Thank you so much for joining me for this explainer today, and as always, keep exploring.